Hello, I want you to imagine something for a minute. Imagine it is a burning hot day and the blazing sun is beating down upon you, parching you out, and you're just about to take a sip of a nice, cool glass of... Stop! Somebody shouts. That's a glass of dihydrogen monoxide, don't drink it! Dihydrogen monoxide? Yeah, it's called H2O as well! H2O? Now, you might be thinking that sounds rather familiar. You look at your glass, but it's just water. And you're right. But do you know what water actually is? Have a think about that for a moment. I mean, the answer might be obvious. You might be saying to yourself, well, yeah, duh, I know what water is, but have you actually ever thought, what's water made of? Well, let's imagine for just a moment that we've got a really powerful microscope and that we're zooming into this little circle of water. Now, what we'd see if we zoomed in would be a molecule of water. Now, what is a molecule? Well, a molecule is kind of like a building block that things are made out of, and the molecules are made of even smaller building blocks called atoms. Imagine Lego. A Lego piece would be an atom, and a molecule is built up of a different combination of Lego pieces. So in this example, our molecule is made up of a green atom, a blue atom, a red atom, and 2 yellow atoms. And then it takes a whole collection of this same kind of molecule to start to make the things that we can see, feel, touch, or taste in the world around us. Well, what about water then? Well, a water molecule is made up of one oxygen atom, like this, and that's right, oxygen is the thing that's all around us. It's the thing that we need in order to survive, to breathe. Right, we'll put an O here to make sure we remember it. But then what makes this different from just any old oxygen atom are the 2 hydrogen atoms on either side like this. And we'll put little H's so that we remember that these are hydrogen atoms. Kinda looks like Mickey Mouse, doesn't it? Hey, that's a good way to remember this. Right, so we've got 2 hydrogens and 1 oxygen. Remember what I called it right at the very start? I called it H2, as in 2 hydrogens. O, 1 oxygen. H2O. So you've probably heard that before, but now you know what it means. Right, so we've talked about what a water molecule is, but obviously there's a lot more than just one water molecule in a glass of water. I've got a challenge for you. How many water molecules do you think would be in an average sized glass of water? I mean, obviously it's going to depend on the size of the glass, but just roughly, how many water molecules do you think there might be? Okay, do you think you've got your answer? Here we go. That's right, I'm not even going to try to say this number, but you get the idea. That's a huge number of water molecules. But wait, there's more. You see, water is a very special substance. That's because it can be solid, in which case we call it ice. It can be liquid, in which case we call it, well, water. And it can be a gas too, in which case we call it steam. Knowing about water molecules helps us make sense of how this works. You see, water molecules are always moving. They just can't sit still, and they'd get in all sorts of trouble if they were in a classroom. When the molecules are cold though, they move kind of slowly. And the colder it gets, the slower they get and the less energy they have. And also the closer together they get, almost as if they're huddling together to keep themselves warm. In fact, they move so slowly and huddle together so closely that they start to form what feels like a solid object. So if you were to put your finger on a block of ice, your finger wouldn't go through it like it would with water. The molecules are all so close together and moving so slowly that you can press down on it and it's a solid object. On the other hand though, if we started to heat the poor molecules up, we'd be giving them loads and loads of energy, so they'd start jumping about wildly, and the more they move about, the more space they need. If you've ever watched a kettle start boiling, you know exactly what I mean. Eventually, they get so spaced out and are moving so quickly that they turn into steam, they turn into a gas. And while all of that is taking place, you might just be seeing some steam rising up from the top of your cup of tea. Anyways, now that you know all this about water, maybe the next time you take a shower or you're squirting your annoying sibling with a water gun, you'll take a moment to stop and think about how amazing something so ordinary and mundane actually is. The world is an amazing place, and sometimes all you have to do is look close enough. Anyway, that's everything from me today. I'll catch you next time.